Hey guys, welcome back. I want to talk about these USB panels. So the 3-port panel, which comes with one car adapter outlet, has actually 18 gauge wires. And I purchased this one to experiment with, and it turns out, because it has 2 car adapter outlets, it has 16 gauge wires, which is good for about 13, maybe 15 amps before they start getting warm. So if you're going to be running the 12 volt appliances, I would definitely recommend getting this. You won't have to deal with upgrading the wires. If you're going to go past 15 amps, then you want to actually hardwire your appliance using an XT60 connector right to your converter. With these, it comes with a 10 amp fuse, and I would replace that fuse with maybe a 15 amp and change the wires to 14 gauge. So that's what we're going to do in this video, as well as I'll show you how to install some XT60 connectors on the end of these wires. Let's get started. We will need red and black 14 gauge wire, our USB panel, and a 15 amp inline ATC fuse. We will also need some heat shrink, 12 gauge spade connectors, wire strippers, wire crimpers, cutters, and some solder. See the difference between 18 gauge wire and 14 gauge wire? Much more rigid. Now we can remove the old wires. You might need a screwdriver to help pop off the connectors. You will need a smaller 14 gauge spade connector for the switch connection. You can find these at your local auto parts store. They sell mainly these 2 sizes. First, we will cut a length of wire that matches the old wire, including the 2 loops. For the loops, we will just cut the remaining wire in half. Here is where you will use the different size connectors. You will need the 12 gauge connectors for the loops because they will hold 2 wires. I decided to use the smaller 14 gauge connector at the end of the last loop. This will connect to the switch negative for the lead and will be the last stop on the negative wire. It should look something like this. First, we will strip the wires, join the loops together, and crimp them both together. Now we can install the smaller spade connector at the end of the last loop. Finally, we can join the 2 loops, completing our negative wire. Now we can apply a small piece of heat shrink covering the entire connector. Having well pressed together connections in any electrical system will reduce resistance, thus reducing heat. We can make the spade connectors fit tighter by using a pair of pliers and closing the small gap slightly. It should still have enough room for the connector to slide onto the spade with a fair amount of pressure. If it slips on with little effort or wiggles left or right, it is too loose. Now we can finish by adding some heat shrink to the remaining connections. This helps with heat as well as prevents possible short circuit. And now the negative connections are complete. Just like the negative wires, we will need to create the loops using the 12 gauge spade connectors. Next, we can crimp the smaller spade connectors for the switch connections. Don't forget to close the gap a bit to create the best connection. So the first pin is our power in, and then when you switch the switch, the second pin is our power out, and this negative is for the LED inside the switch. This is 12 gauge wire, and we're using 14 gauge connectors. Well, this is 14 gauge, and these are 12-14. So I could not find, I don't know if they make 14 gauge in this size, and this wire is too thick to go in there. So what we're going to have to do is use a small piece of 14 gauge wire, and we're going to have to do something like this. Put that in there, and use a butt splice connector and adapt it to the larger wire like that. For the fuse, you could just use a 15 amp fuse installed onto a 14 gauge wire. Then you would not need to splice connect the 14 gauge wire to the 12 gauge wire. I'm using a 12 gauge butt splice connector. Crimp the connection. Now we can add some heat shrink tubing, and finally apply heat. Okay, now our USB panel is complete. Now we can test it. Okay, now we got the panel hooked up to our test battery, and we can see if it works. Cool, everything seems to be working. For this, we are not going to use butt splice connectors. Instead, we will use only solder. We will need a couple of pieces of heat shrink tubing. Let's clamp the XT60 connector. Solder the positive wire, and then the negative. Now we can apply our heat shrink tubing. Yeah, there it is. And now I have MC4 to USB. Let's see how quick this responds when I connect the battery. Pretty cool, man. Alright, so I hope this video was useful. I wanted to keep it short because I had merged this with the other video about the other buck converter, but it was too long. So I wanted to do the wires separately, and if you guys want, send me some pictures of the projects you have built with this, and yeah, I'd like to see it. And thanks for watching.